Hi all! Let's jump into a demo of one of the key features of AG2's 0.6 release, ReasoningAgent's Monte Carlo Tree Search. Let's look at how AG2's Reasoning Agent leverages Monte Carlo Tree Search, or MCTS, to enhance its decision-making capabilities. When receiving a question, our Reasoning Agent will create a thinking node, or root, for the question. At this stage, the agent hasn't explored any options yet. The root stats are straightforward: the number of visits, 0, and the value 0. Here we use n to represent the number of visits and val to represent the value, which is usually between 0 and 1. Because initially the root does not contain any children, we perform expansion. This process builds a list of possibilities for the next step's reasoning. We add 3 new child nodes representing possible next actions beneath the root, each represented by green circles. Each child signifies a different reasoning direction, and at this point they're all equally unexplored, with visit 0 and value 0. Once we have these options, the MCTS algorithm decides which child node to explore next. Because all children have the same value 0, it actually randomly selects one child to proceed. For this example, let's say the algorithm picks the middle child for deeper exploration. We highlight this chosen child in yellow to show our focus. From our selected child, we perform another expansion step. As depth goes on, MCTS breaks down the problem into smaller, more manageable stages, creating a budding tree of possibilities. Let's say we want maximum depth of 3, and now the agent randomly selects one of these leaf nodes, T2.1. Then the reasoning agent provides an answer based on the thinking process. Finally, the reasoning agent evaluates the answer, resulting in a value of 0.6. Now that we have a value for this leaf node, MCTS performs backpropagation. This means updating the stats on all the visited nodes along the trajectory. Visits is 1, value 0.6, marked by the yellow arrows. That's the end of the first simulation. After one simulation, we reset the highlights and prepare for more simulations. Remember, MCTS is an iterative process. The more simulations we run, the better the tree's statistics guide us toward the best branch. From the root, we have the same 3 children in the first layer. Then we want to randomly select a child to proceed. This selection decision, based on UCT, or upper confidence bound applied to trees, balances 2 factors: exploration, testing out less visited paths to uncover potentially valuable new areas, and exploitation, focusing on paths that have already shown promise. This time, we randomly selected the first children in the first layer. Then we expand again. At the second layer, we randomly selected the middle child, and then generate the answer based on this thinking trajectory. Finally, we evaluate the answer, and suppose this answer yields a higher value, 0.8. We then propagate again, and now the root's average improves, reflecting both the 0.6 and 0.8 results. The root may now display visits to and value 0.7, where the value is the average across all previous visits. Let's add a third simulation. This time we used UCT and randomly selected the first child in the first layer and the first child in the second layer. Similarly, after getting an answer based on this thinking trajectory, we evaluate the answer and get the value 0.4. After backpropagating this result, the root updates to visits 3 and value 0.6, averaging the 0.6, 0.8, and 0.4 results. After running several simulations, MCTS can identify which branch consistently yields better values. And over time, the agent gains confidence in selecting the path with the highest average value. Eventually, the algorithm points us toward the most promising final answer node, which in this case is A1.2 with a value of 0.8. This answer will be returned to the user. Now that we know how MCTS works with our reasoning agent, we'll quickly run through the notebook on the AG2 website that demonstrates a reasoning agent with the MCTS search strategy. The notebook includes another 2 strategies, Beam and Language Agent Tree Search, or LATS. We'll just run through what's needed for MCTS. First, the LLM configuration. And in this cell, we also have the question that we're looking for reasoning on. What is the expected maximum dice value if you can roll a 6-sided dice 3 times? Then a support function, last meaningful message. And we scroll down to MCTS, create our agents, and initiate the chat. That will go through the reasoning process we discussed. And after a few minutes of deep thought, it finishes with our answer, which is approximately 4.96. Thanks to the community and contributors that made this release happen.